In this video, I'm going to talk about Faraday's experiments. By now, you should have watched the video of electromagnetic induction in action, a current being induced in a coil even though there was no battery in that coil. So this is what Faraday did. He did a few experiments, and he discovered something very, very important. One of his experiments was as follows. So you can see that there's a coil of wire and it's connected to a battery, but on the right hand side the coil of wire is just connected to an ammeter device that measures the current. So there's no battery on the right hand side. But as he closed the switch on the left hand side, then what happened was that the needle deflected on the right hand side. So somehow closing the switch here created a current in this circuit which is not even connected to this circuit. So you can start thinking about what happened, but it will become more apparent as we look at others of his experiments. So in another experiment, what he did is he placed a coil, and this one had a battery attached. And when he closed the switch, guess what happened? Then there was a current induced in the bottom wire. This only happened when he closed or opened the switch. So do you have an idea of what could have caused the current in the bottom loop here? One thing that you should think about is the fact that we learned that when there's a current in a loop, such as in this top loop, a current produces a magnetic field. So when the switch is open, there's no magnetic field. When the switch is closed, there is a magnetic field. What this means is that the magnetic field through this bottom loop is changing as you open and close this switch. This next experiment is similar to what you saw in the video, where you push a bar magnet into and out of a coil, and once again, the ammeter reads a current, only as you bring it into and out of the loop. If you just hold it stationary, nothing happens. Finally, a very similar experiment shows a loop of wire that is being brought into and out of a magnetic field. So what is happening in each of these experiments is that you are changing the amount of field that passes through these loops, and that is what seems to be causing the current in that loop, even though there's no battery in that loop. So to summarize, a current is induced when the magnetic field passing through the coil is changing. Actually, it's not quite that easy. What is really happening is that the current is induced by a change in magnetic flux. So the next thing that we need to do is understand what is meant by magnetic flux.